Okay, now I move on to question 5 of exercise 10.1. The first thing that we have to prove that is triangle ABC is similar to triangle CDB. Alright, these two triangles. Okay, first and foremost, right, please do not go and assume that these two lines AC and BD are parallel. Many will just say that these two lines are parallel. Please don't do that. We actually have to prove it. Okay, so how do I say this? Okay, I say that first angle BAC, alright, is equals to angle DCB. Okay, never mind. Angle BAC is equals to angle ABD equals to 90 degrees. So this is given as shown in the diagram there. Next thing that I know is this. Since right, these two are 90 degrees, so I'll say that angle BAC plus angle ABD equals to 90 plus 90 degrees is equals to 180 degrees. So by writing this statement, right, okay, I've shown that by interior angles, okay, I've proven that because the sum of interior angles is equals to 180 degrees. Since these two angles add up to 180 degrees, I have shown that AC is parallel to BD. Okay, since interior angles only works right with parallel lines, then now I can say this. By alternate angles, okay, this angle will be equal to this angle. So in short, I have proven that angle ACB is equals to angle CBD. Okay, which is by alternate angles, okay, parallel lines. That's angle ACB. So I've proven these two angles are equal. Still not enough, alright. I have to prove one more thing, okay. I will actually have to say that angle BAC is equals to angle DCB. Angle BAC is 90 degrees down here is equals to angle DCB is equals to 90 degrees given. Okay, so these two angles are equal and then these two angles are equal. Hence, okay, I've proven that triangle ABC is similar to triangle CDB, and the reason here being angle similarity. And we are done with question 5 part 1 to prove that triangle ABC is similar to triangle CDB. That's 5 part 1. Okay, now we move on to 5 part 2. 5 part 2, they want us to prove that AC times BD is equals to CB square. Alright, now how we start this question is like this. Okay, first I look at what they want me to prove. Okay, they want me to prove that AC times BD is equals to CB square. So if you notice here, I have to use AC, I have to use BD, I have to use CB twice. Okay, then if I think about it, what I can do is I use the result from part 1. So I say from 1, alright, triangle ABC is similar to triangle CDB. It is from part 1. Then I think, okay, I will probably need AC. So I look at this triangle, so I take AC, first and third vertex. Okay, then I look, it will be over CB. Then now I have to make a decision. Should I use, from this triangle, I've taken AC already, should I use AB or should I use BC now from this first triangle? If I look at what I have to prove, it's quite clear I should use CB. So I'll use CB over third and second vertex BD. So I write there CB over BD. Then quite simply, alright, if you multiply both sides by BD and CB, I will get AC times BD is equals to CB squared, and I have proven. And I'm done with question 5, part 2. I shall now move on to question 7. Okay, this is the diagram for question 7. Question 7 is actually not that difficult. Alright, first they want us to prove that DE is parallel to BC, and it's also given that D and E are the midpoints of AB and AC respectively. So in this case, right, D is a midpoint of AB and E is a midpoint of AC. So immediately I can say that by midpoint theorem, okay, comma, DE is parallel to BC, because D is the midpoint of AB and E is the midpoint of AC. So straight away I can just quote that DE is parallel to BC. Okay, since D is the midpoint of AB and E is the midpoint of AC. So therefore DE is parallel to BC. Just by writing one simple statement, I have proven that DE is parallel to BC. The next one, they state if BC equals to 2x, explain why DE equals to x. Okay, so now, okay, I just say that by midpoint theorem, I know that DE is equals to half of BC. Okay, I also know that BC equals to 2x. Okay, so since BC is equals to 2x, comma, DE is half of BC, which is 2x. So half of 2x is simply equals to x. And I've proven that DE equals to x. And I have shown. Okay, is it shown? Yes, I have. No, explain. Yes, so I've shown that DE is equals to XCM. And we are quite simply done with question 7. Alright, stay tuned for the next video where we'll cover questions 14 and 17.